Hello, chemistry students. Today we will be continuing our qualitative analysis experiment with the analysis of an unknown mixture of cation ions. This mixture will contain cation ions from several of the metal ion groups that we have previously studied. Let's get started.
This is the unknown solution that we will begin with. We will start by adding 3 drops of 6 molar hydrochloric acid to our solution and stirring with a glass stir rod and then centrifuging. This is what our mixture looks like after centrifugation. We will next decant the solution into a new test tube labeled S1 and then test for completeness of precipitation by adding 1 or 2 more drops of 6 molar hydrochloric acid to solution S1. No more precipitate has formed, so precipitation is complete. We will save solution S1 for later analysis. And we will relabel our residue as residue R1. We will next wash residue R1 with 1 milliliter of deionized water. We will stir the mixture, centrifuge, and discard the wash liquid. To residue R1, we will next add 3 milliliters of deionized water and then heat the mixture to near boiling with stirring. We will then centrifuge the heated mixture and after centrifugation, decant the solution to a new test tube labeled S2. We will next relabel our residue as residue R2, and we will wash residue R2 with several portions of boiling hot deionized water. After each washing, we will centrifuge and discard the wash liquid. We will next add several drops of 1 molar potassium chromate to solution S2. Next, to residue R2, we will add 1 milliliter of 6 molar ammonia and 2 milliliters of deionized water and stir. We will then centrifuge the mixture and decant the solution to a new test tube labeled S3. We will next acidify solution S3 by adding 6 molar nitric acid dropwise until acidic. Next, to solution S1, which we had previously set aside, we will add 6 molar ammonia dropwise until the solution is just basic. Once the solution is just basic, we will add 1 drop of 6 molar hydrochloric acid per milliliter of solution in the test tube. We are aiming for a 0.3 molar hydrochloric acid concentration in our solution. We will next add 10 to 12 drops of 1 molar thioacetamide to solution S1 and then heat the solution in a boiling water bath for 10 minutes. After heating for 10 minutes, we will centrifuge the mixture. This is what our mixture looks like after centrifugation. We will next decant the solution into a new test tube labeled S3A and save test tube S3A for later analysis. We will then relabel our precipitate as R3 for residue R3. We will next wash residue R3 with 4 milliliters of deionized water and 4 drops of 6 molar hydrochloric acid. We will stir the mixture, centrifuge, and discard the wash solution. Next, to residue R3, we will add 5 drops of 6 molar sodium hydroxide and 1 milliliter of deionized water. We will stir the mixture well and heat in a hot water bath for 2 to 3 minutes. After that time period, we'll remove the mixture from the hot water bath and allow it to cool. After the mixture is cooled, we will add 5 drops of 3% hydrogen peroxide. We will then stir the mixture and heat in the hot water bath for an additional 5 minutes. After heating the mixture for approximately 5 minutes, we'll remove the mixture from the heat and add 5 drops of 1 molar thioacetamide and 5 drops of 6 molar sodium hydroxide. We will then stir the mixture and heat for an additional 2 to 3 minutes. We will then centrifuge. This is what our mixture looks like after centrifugation. We will next decant the solution into a new test tube labeled S4 and save test tube S4 for later analysis. We will then relabel the residue R4 for residue R4. We will next wash residue R4 with 3 milliliters of deionized water, 1 drop of 1 molar thioacetamide, and 1 drop of 6 molar sodium hydroxide. We will stir the mixture well, centrifuge, and discard the wash liquid. To residue R4, we will add 1 milliliter of deionized water and 1 milliliter of 6 molar nitric acid. We will then stir and warm in a hot water bath to dissolve the sulfides, and then we will centrifuge. After centrifugation, we will decant the solution into a small beaker and add 2 milliliters of 3 molar sulfuric acid. We will then place the beaker on a hot plate and evaporate the solution until the beaker is almost dry. After the beaker is nearly dry, we'll remove the beaker from the heat and allow it to cool. After the beaker has cooled, we will add 3 milliliters of deionized water to the beaker and stir. We will then transfer the solution to a new test tube and centrifuge. This is our solution after centrifugation. Note that there is no precipitate in the test tube. We will then transfer the solution to a new test tube labeled S5. We will next add 6 molar ammonia to solution S5 until the solution is distinctly basic. After centrifugation, you can see that we have a dark blue solution with no precipitate. Next, to solution S4, which we had previously set aside, we will add 3 molar sulfuric acid dropwise until the solution has been neutralized. After the solution has been neutralized, we will add an excess of 3 molar sulfuric acid equal to 1/3 the volume of sulfuric acid needed for neutralization. After we have added the required amount of sulfuric acid, we will centrifuge the mixture. This is what our mixture looks like after centrifugation. Next, to solution S3A, which we had previously set aside, we will add 1 milliliter of 3 molar ammonium chloride. We will then add 6 molar ammonia dropwise until the mixture has been neutralized. After neutralization, we will add an additional 0.5 milliliters of 6 molar ammonia to our mixture. Note that after the addition of ammonia, there is no resulting flocculate. Next, without centrifuging, we will add 10 to 12 drops of 1 molar thioacetamide, stir well, and then heat our mixture in a hot water bath for 5 minutes. After heating for 5 minutes, we will remove the test tube from the heat, add an additional 0.5 milliliters of 6 molar ammonia, mix well, warm it slightly, and then centrifuge. This is what our mixture looks like after centrifugation. Note that there is no precipitate. We will then transfer the solution to a new test tube labeled S9. We will next acidify the solution S9 with 6 molar hydrochloric acid. We will then heat the solution in a boiling water bath for 5 minutes.
After heating the S9 solution and evaporating the total volume down to 3 to 4 milliliters, we will next add 3 molar ammonium carbonate dropwise to the solution until it is just basic. After the solution is just basic, we will then add an additional 1 milliliter 3 molar ammonium carbonate. We will then mix well and allow the solution to stand to complete any precipitation. After allowing precipitation to complete, we will next centrifuge the mixture.
This is what our mixture looks like after centrifugation. We will next transfer the solution into a new test tube labeled S14. And we will save solution S14 for later analysis. We will relabel the residue as residue R14. We will next wash residue R14 with 1 milliliter of deionized water, then centrifuge and discard the wash liquid. Next, to residue R14, we will add 5 drops of 6 molar acetic acid. We will stir and then warm the mixture gently in a hot water bath to dissolve the carbonates. After the carbonates have dissolved, we will add 5 drops of 3 molar ammonium acetate. We will then dilute the solution to a total volume of 1 milliliter using deionized water. We will next add 3 drops of 1 molar potassium chromate to our solution, and then we will stir, warm, and centrifuge our mixture. This is what our mixture looks like after centrifugation. We will next transfer the solution into a new test tube labeled S15 and set aside for later analysis. We will then relabel our residue as R15. Next, to residue R15, we will add 3 drops of 6 molar hydrochloric acid and 2 milliliters of deionized water and stir. We will then add 2 drops of 3 molar sulfuric acid and centrifuge. This is what our mixture looks like after centrifugation. Next, to solution S15, which we had previously set aside, we will add 10 drops of 1 molar potassium oxalate. We will then add 6 molar ammonia dropwise until the solution is basic. Once the solution is basic, we will allow the solution to stand for 10 minutes to see if any precipitate forms. After 10 minutes, no precipitate has formed in our solution. Next, to solution S14, which we had previously set aside, we will add 1 milliliter of 6 molar ammonia and 0.5 milliliters of 1 molar sodium dihydrogen phosphate. We will then stir the solution intermittently for 5 to 10 minutes. After stirring our solution intermittently and allowing it to stand for 30 minutes, you can see that no precipitate has formed in our solution.
Okay, students, you can now determine which cations were present and which cations were absent in our unknown solution. This concludes the qualitative analysis experiment. Thank you for joining me for this laboratory.